Welcome, everybody. As you're seeing right now, this is the very first contact of the partial solar eclipse. We are over here in Norwalk, California, as it's fading out of view, and I'm going to have to manually track this as we're going on. I'm Scott Lewis from Know the Cosmos, and with me from Melbourne, Australia, is Dr. Katie Mack. How are you doing, Katie?
I'm all right. I just got up, so it's kind of early here.
Good morning,
It's 8
friends.
a.m.
Yeah. Well, it's not like there are other hangouts that we do where I stay up really super late. And,
Right.
yeah, and I am having to really jury-rig this as I wait for it to get going. So I apologize about the image going in and out, but there we go. We're now seeing the moon. And so what we're doing out here at Cerritos College is actually Dr. Thad Szabo, who is finishing up getting connected, is with his students as partner instead of a normal lecture. He's actually having them out here looking at and it's hot, and I'm waiting on Thad. No pressure, Thad. None whatsoever. It's a little windy out here too, so that's why you're seeing everything move. And I'm trying to fix her focus as we're going on. They just got out of a Hubble hangout, so if you didn't see that was on Comet Sighting Springs, which is really awesome. There, it's a little bit better. And now we are watching the moon go in front of the sun. So, Katie, what can you tell us about what's going on? And is there any connection between the lunar eclipse that we just experienced here in Los Angeles a few weeks ago?
What's the alignment between the Earth and the Sun are perfect. So there's the Sun and the Moon and the Earth, and so the Moon is coming between the Earth, between us and the Sun, and that alignment has to do with sort of where everything is in its orbit, and so it's not unreasonable to think that it would also be the case that a couple of weeks ago, when the moon was on the other side of the Earth, the shadow of the Earth would have perfectly aligned with the moon. So there is a connection in that that alignment is pretty good, and so on either side of that, of the sort of the moon's orbit, you can get that alignment going.
And you're breaking up a little bit. I don't know if it's your connection out there. I know Australia has some amazing internet connection, but it also might be me because I'm on a Wi-Fi connection since I'm outdoors. So, because we did just have a lunar eclipse, and we know that we're not seeing these every single month for a reason, because the orbit of the moon is not directly in line on the same plane as ours is with the sun. It's about, what, I think it's like 5 degrees off? Is that about right?
I don't remember, but it's a small angle off, yeah.
A very small angle off. And so every once in a while, they will coincide, which is why we're seeing this. Now, we're not going to see a total eclipse today. We're going to be seeing a partial. And so right now, we just had first contact about 7 minutes ago, and we're going to be watching it slowly meander across the top here and then float away. But what I'm really loving is we can see this very active region. I think it's called AR2912, I believe is the official designation of it, and it's awesome. I'm going to see if I can try and zoom in on it too.
It's about the size of Jupiter. That sun is about the size of Jupiter. Huge.
Let's see if I can bring that back into focus here and zoom and enhance, all CSI style. There we go. What is going on? What when I know that you are not a solar physicist, I should have Ian on here, solar physicist. But when we're talking about an active region, AR 2912, that big, you're seeing those big sunspots there. What's going on as we're looking at that?
Your side at the moment.
Yeah, there are a lot of students out here.
Okay, so sunspots and active regions, things like that, all those features on the sun are basically disturbances in the magnetic field on the surface of the sun. And so when you get a sunspot, it's because there's a sort of like hole in the magnetic field that makes a little bit of a colder spot in the center, and then there's sort of active sort of magnetism swirling around at the edges. And so you can get these active regions where you have stuff being flung out by complicated things going on with the magnetic field, and that's where you can get things like solar flares and coronal mass ejections and all of that kind of thing. So it's all these little magnetic reconnections and things going on, getting complicated with the field lines at the surface of the sun.
And it's being, because the surface of the sun is extremely magnetic and very tumultuous on there, and so we're seeing this fluctuations going all over the place, and so it ends up being a little bit cooler, and which looks darker to us because it's not as hot to emit all that out. And I'm really sorry for being scattered, because normally I have notes and everything with me, but I've been all over the place today, and I'm outside with a bunch of people, and it's early for you, and it's okay.
Yeah, it's fine.
I do want to make a special shout out to a few people that helped promote this. So I did want to do a shout out to Sandon Totten from Southern California Public Radio at KPCC. He's embedded this over at kpcc.org, and also to Dr. Phil Plate, the bad astronomer himself. He went and included links to everything there, and everybody else on social media. I've been seeing a lot of links out to our show. My favorite space chicken in the world, Camilla Corona, tweeted it out a little while ago. So thank you to everyone that's helped raise awareness on getting this out, because it's not something that's available everywhere in the world. It's actually only in the northern part of North America.
Yeah.
And for most places, they're actually not going to be able to see much. We have a fairly clear day out. There's some clouds, but we shouldn't be too much of a problem out here with us.
No, I can't see the eclipse at all from here.
Not at all?
No.
What about in this hangout? Can you see in this hangout? Huh?
Yeah.
Yeah. Now, didn't you guys just have an eclipse down in Australia a little while ago?
Well, we had the lunar eclipse just a couple weeks ago, and we had a solar eclipse. I don't remember. It was maybe last year or something like that. We had one also. We had a partial solar eclipse in late 2012, I think.
Right.
So I was able to see that from here. I didn't.
And then last time you and I did anything, we actually did the lunar eclipse a few months back from the same location of where I'm at right now, which was really awesome, because that's over here. You were over in Australia, which I thought was just amazing. It made me happy.
Yeah, so the cool thing about lunar eclipses is that because the whole moon is in the shadow of the Earth and the shadow of the Earth, anywhere on Earth where you can see the moon, you can see the lunar eclipse. With solar eclipses, the shadow of the moon on the Earth is tiny, and so you just have to be right in that shadow.
You have to be just right in that shadow. I'm trying to, I know that there are some questions and comments, and I will be trying to get to them as we're going along, pulling all that up, and also trying to share and tweet out that we're live too. So do you want to tweet out everyone out? I'm seeing we have quite a lot of viewers so far, so hello everyone. If you want to ask us questions or anything like that, we do have the Q&A app installed and ready to go over here on Google Plus and on YouTube. Also, you can tweet at us. So I think put up Astro Katie. You're not Ellen Duffy, who's Astro Duff. You're Katie Mack, and your Twitter handle is Astro Katie, which you can't really see right now. I'm not going to be able to put up my lower third, but I am at Scientific Scott on Twitter. And this is at Know the Cosmos on Twitter and knowthecosmos.com. And yeah, there's event pages on Facebook and Google+. So what I'm hoping for, too, is since I have been putting out the event page on Google, if you guys are having any pictures that you're taking yourself of the eclipse, safely being the key word, if you've taken any great images of it, please share them with us on the Google page, on the event page. I've turned it on so people can share their images. And if it's not coming through, I'm sorry, and I will make sure to get that turned on as we go along. Let's see here. I'm going to go through here. One from Russell Bateman I'm going to laugh at. He says it kind of looks like the Apple logo. Yeah, kind of. Or any fruit that you take a bite out of. I would say it looks more like a bitten orange logo with a spot on it. And Nafish Riaz is asking where. Now, I did have an image. Let me see if I can find it and screen share it real quick before I put it back. Before I put the eclipse back on. Unless you have that map up. Do you have that article I just posted a little while ago? I put it up on the social medias because it has that map.
I will look for it. Hold on.
Nope, I found it. I found it. Let's screen share this. So real quick, I'm going to. So this is the area in the world where it's going to be able to be seen. It's right down here in Southern California. Katie is over here in Australia. And so we're going to see more of an eclipse, and down in the southern area we'll be seeing less of an eclipse. So this is the only areas we'll be able to see this particular eclipse, but they happen all over the place. They don't just happen. I just lost my camera. No, come back to me, camera. Here we go. And I will be talking over my shoulder real quick. It's what are you doing with your camera? Don't unplug the telescope. So this is a public service announcement for anyone out there trying to do auto tracking with the telescope. Don't unplug it because it stops auto guiding, and so he's getting that back up and going. I'm going to go through some more of these. Oh wow, I have a bunch of questions. So thank you guys all for using the Q&A app. If you don't know how to use that, you're using that now. If you're on any embedding of this, of the YouTube version, on the lower left-hand side, there'll be some yellow things, and then I will be able to see them and select them. So there will be timestamps on when I'm answering them. Russell Bateman just actually updated me here that it's active region 2192. So I think I might have said that a bit wrong. I apologize. And I will be sharing, he put up an amazing image of 2192 a little bit earlier, and I will find that and share it out because it is amazing. It's absolutely gorgeous. If and I did put it out on Twitter a little bit ago while I was on during a couple hangout. But let's move this over a little bit more, get a little bit more focus. There we go. And so yes, so the reason why this is so shaky is I am hand guiding this. So I don't have the convenience of unplugging my telescope. I am using a very nice or kind of stable tripod and binoculars and a webcam with a white light filter. So I think this is a good time before we get Thad's camera up. Can you, Katie, explain to us what the difference is between the type of filter I'm using, a white light filter, and the Coronado, the hydrogen alpha filter that we'll be using in just a little bit? Can you go over the details of that?
Yeah. So if you're using a filter on your telescope. What you're trying to do is block out most of the light and just try and see certain wavelengths. So if you're just using white light, then you're seeing sort of the whole visible spectrum. But sometimes it's useful to get just a little part of that visible spectrum, just a certain wavelength, so that you can see particular kinds of features. And one of the coolest ways to look at the sun is with a hydrogen alpha filter. Mm-hmm. And that's one where you're just looking at the hydrogen alpha transition of neutral hydrogen. So this is a transition of hydrogen between two energy levels, where the electron is moving between two energy levels, and that gives you a photon, and that photon is sort of orange color. It's the wavelength to be the right wavelength to be a kind of orangey color.
Right. And so I believe, if we want to get technical, it's jumping from the third to the second energy level, and dropping that level. That's when that photon's released, and it's at a very particular wavelength. I want to say it's like 625 meters, I think, is the wavelength of it.
I don't remember.
Something along those lines.
Let me show you.
I wrote about it.
I found a nice.
Yes, share.
I found a nice picture of H alpha, the H alpha sun. I'm going to show you that on screen share. So this is a beautiful image of the sun in H alpha, and you can see that these little sort of swirls on the sun, and those are convection cells as the solar surface gets sort of whirled around by its own heat. And you can also see a lot of features due to magnetic fields, where you can see dark regions and bright regions. And those are sort of complicated things going on with the magnetic field on the surface of the sun. And you can see at the edge of the sun these little prominences and flares. And those are bits of the magnetic field extending out into space, and sort of being visible at the edge. So these are these features really come out when you look at the sun in hydrogen alpha, because you're seeing the parts of the sun that are at just that wavelength. So that really helps you to pick out a particular part of the surface of the sun.
And so, what we're looking at now on mine, as it's getting a little bit blurry as I need to move it along, is I'm blocking out 99.98, I think, of the visible light, of just visible light. That's all I'm going through, and dealing also with my mounting of my camera getting all wonky. So I apologize about that as I try to fix it while doing all this. Brighten that up a bit with my exposure settings. There we go. And Thad's also getting this stuff on. So what we're doing is we're just blocking out the entire spectrum, the full broadband of light coming through, and we're just decimating it. We're taking it down so only a teeny tiny bit of it comes through, so we can safely look at it. And oh, this image is awful. So let me see if I can pretty this up a bit. There we go. Lower my exposure settings. And fix my focus. That's better. It's oblong, but it's a little bit better. And so when you don't, for those out there that don't really know how to get into any sort of astronomy and stuff like that, I'm literally using a pair of $70 binoculars. I got a set of white light filters I think I got from Amazon for $25, and I'm using a Microsoft webcam. And I have that all set up, just kind of taped and jury-rigged together. But this is really easy way for you to get into observational astronomy. With the white light filter, you're able to see things like the sun, and be able to see these active regions. But also, you can take them out at night and see some really great objects too. with just binoculars. And you don't have to go out and buy an extremely expensive telescope to be able to do a lot of really cool observational astronomy by yourself.
Yeah, with binoculars, you can see the shape of Saturn, the moons of Jupiter. You can see Mars being kind of little and red. You can see a lot with just binoculars, and of course the moon looks amazing if you get more detail.
Oh yeah.
So.
The moon looks absolutely amazing. So I mean, it's like what we're looking through here is literally what you'd be looking through, because the moon is roughly the same angular size to us as the sun. So you're looking through, and you're able to see some really great detail of the moon. And if it's a full moon, I have to actually try to dim it down a bit. It's really super bright because even though the surface of the moon is darker than asphalt, there's so much light being reflected at it. Looking at it with these optics, you're actually getting a whole bunch of light. So it seems really bright just looking through these telescopes or through these binoculars.
I found a couple pictures of the active region on the sun. I'll share a little bit of that. So, this is a picture from the Soho Observatory webpage, and you can go there and see live new pictures of the sun. And you can see that active region here really clearly in that image, and you can see a couple other little sunspots near the edges of the sun. But that region is really obvious. And then if you go to another part of the web page, you can see pictures of the sun in all sorts of different frequencies, and you can see from pictures of just the corona of the sun, where you've blocked out the main part of the sun. And so if you go into those pages, you can see sort of how the different wavelengths of light show different aspects of what's going on the sun. And some of these are really spectacular, so you should definitely check out this website.
Oh, definitely. And as this is slowly loading, because I am broadcasting and trying to download on a Wi-Fi network, Russell, like I was saying earlier, Russell Bateman has taken some of his own images, so I'm going to screen share this as it's loading up slowly, and hopefully this will start coming through. So this is his, and I do totally recommend giving him a follow. He's one of our astronomers on the Virtual Star Party. And this is that active region that we're able to see clearly with the naked eye. Well, okay, the naked eye through a filter of
not naked eye.
Not burning your eyes. The shielded eye.
Quickly shaded eye.
Yeah, the shielded eye where you do not burn and melt your eyeballs. But
don't look at the sun, people. Don't look directly at the sun. Seriously, not a good idea.
Your Ray-Bans, your sunglasses will not help. You need a very specific type of glasses. They do have eclipse glasses there for you to help out. But do not try to look directly at the sun ever, but also, especially when the eclipse is going on, because actually ends up especially it darkens down a little bit, your pupils will actually dilate a little bit more, and you let even more of that harmful radiation. So let's get my view back in here. Let's make fun of Thad a little bit more. What's going on, Thad?
Still trying to focus.
Focus, my son. Focus. Use the force. Use the force.
No, I just pushed the scope over.
Stop pushing the. Don't use that force. That's called work. It's different. Come on, physics professor. Something moved. All right, so I'm going to go back to our Q&A app. I'm seeing a lot of awesome stuff over on Twitter. Patrick Calhoun put up a great picture, a great selfie of him with his glasses on, his solar glasses being safe. So go on with your bad self, Patrick. And let me pull up the Q&A app again. So there are some things going on here. Let's see. So Adams Energy says, how do the sun and moon always know not to waste their time showing the cloudy, rainy UK an eclipse. Well, you know what? Why would you if you know that you're not going to be seen anyway? I know I wouldn't. But no, you get eclipses and stuff like that throughout the entire world. You just happen to be in the UK, and it's never, ever sunny that I've seen. Okay, it's sometimes sunny, but then people stay indoors.
Sometimes sunny.
Yeah, but then you stay indoors.
I went to I was at a solar eclipse a total solar eclipse in England, many years ago. It was amazing. It was cloudy, so I didn't actually get to see the eclipse directly, but it was actually still pretty amazing because I could see through the clouds. I could see the shape of the sun changing, and when totality occurred, although the sun was behind the clouds, it got really dark, and it was like nighttime, and it was like there was a sunrise all around the horizon, and it was fantastic. Even though I couldn't see, sort of the beautiful corona stretching out, it was still amazing to watch.
I've realized, even I've been able to see some eclipses throughout my childhood and lifetime, and it's weird because I find that I guess maybe now I'm more of an official nerd, that I really, really get excited about them, because now I know the specific ways that I can do things and really explain what's going on. But it's still really exciting and to a lot of people very mysterious. It's like, what's going on? Why isn't this happening all the time? And so I think people like you and I are very fortunate to where we not only get to be excited about these things, because it's super, super cool, but now we also get to explain it to those that might not be able to understand on a daily basis on what's really going on here and why we're able to see these things. And I love seeing that now it looks more like a yawning Pac-Man instead of, it's like, oh, I just ate all those ghosts and I'm kind of tired. And it will be moving for a little bit more. We're going to, in about 45 minutes is when we'll see the most maximum portion of this eclipse, and the Pac-Man will be yawning even more, and we'll find out what it looks like then. I don't know what it will be then. I'm going to click another here from the Q&A app. Our friend Nicole Gallucci, at Noisy Astronomer on Twitter, follow her, she's awesome. She goes, "Hi everyone, quick check on sun noms before I head out. It's cloudy here." So I think she's checking in. But yeah, she's over in Southern Illinois, in the U.S. here, but she got clouded out, so she's just checking in. So hi, Nicole. I love you, I miss you. You're my favorite radio astronomer. I think you're my only radio astronomer that I know. So there's that too. Let's see here. Oh, so many awesome questions. Is it going to start soon? No, it's already started. So there you go, Nikke Koivisto. So thank you for that. And I'm going to pull up something, and I completely forgot what I was going to put up. Oh, so this one's from Guido Bibra. So he's checking in from Germany. So hello to Germany. That he is jealous. He's so jealous of you folks over in the U.S., but I'm glad that I can watch at least virtually thanks to the magic of the internet. So it's one thing that I've noticed too with our many different broadcasts that we have done, is that this is not something that just goes locally, even though it's a local event here. But I do check my analytics afterwards, and all of our broadcasts really get seen all across the world. The ones that you and I do fortnightly on Conversations with an Astrophysicist, where we are going to be picking up soon the cosmic microwave background, CMB, not CMBR. But no, it's great to see that we're able to help participate in bringing the knowledge of astronomy to the entire world and not just to the small sections. And I know that there are some classrooms right now that are having this fed in there, so I think that's really cool. And I also have a comment here from a cohort, and one of my good friends is Fraser Kane, the publisher of Universe Today. He says, "Hey Scott, great coverage. Totally cloudy here on Vancouver Island," which I think is the same thing as the UK. I don't think they ever get much sun, but hello Fraser, and Thad, whom I call Astro Jesus, looks like he's preaching, and it's awesome. And he's preaching the awesomeness of astronomy to a bunch of awesome students here at Cerritos College. And what are you sharing right now?
So I'm having some fun going through the Solar Dynamics Observatory website, which is a great website where they have pictures of the sun at lots of different wavelengths, and this is a picture of the sun in three different wavelengths, which I think are some kind of ultraviolet, although I'm not sure. And you can really see just fantastically that sunspot, and you can see how active that region is and how unusual it is compared to the other sunspots. How it really is much more active and sort of much more spectacular than stuff going on around it, which is pretty cool.
So yeah, like keep that image up, and then we're gonna compare it back to my image that we have up right now. So this again is just blocking out a lot of the light, just a percentage. We're just dimming it down so we can see it. This is what it looks pretty bland. We see kind of, oh look, there's this little cool spot going on. What's that? And then I switch back over to Katie's image, and that's what's going on. This was really going on in all the different wavelengths, things that we weren't able to see with our eyes.
So I think this is sort of ultraviolet X-ray range.
Okay.
Very bright or very hot gas, and this is showing us the solar corona. So the solar corona is this extremely hot stuff. The sun on the edges of the sun, and it's produced by the magnetic field action of the sun, and it gives you these really bright, really hot sort of flaring regions.
Flaring regions of the sun. And you bring up something that it's still a big is the surface, or not the surface, but the corona, able to emit in X-rays, because emitting light at those temperatures, to be able to emit light at those frequencies and wavelengths means that it has to be super extremely hot. And we already know that the surface of the sun is what, 5,200 Kelvin? And so to be able to emit light in those wavelengths and frequencies, it needs to be around, what, 1 million Kelvin or hotter?
Yeah, it's around 1 million. Yeah, and so last I checked, it was still a little bit of a mystery why the corona is so much hotter than the surface. But it basically has to do with the fact that the magnetic field interactions are so powerful there. And in the center of the sun is hotter. The center of the sun, where the nuclear reactions are happening, is really hot. But the surface that we see, especially the surface that we see like in the H alpha images, itself is cooler. That's the part that's where the radiations come out, and it's sort of the edge of where the hot plasma is. But then you have these magnetic field events going on, creating this corona, and that itself is a lot hotter.
Yeah, because in the core there, that's where we're having those, the thermonuclear reaction. We're having, like, atoms themselves aren't able to be, staying together. There's so much pressure and so much energy being released and bouncing all over the place. Hydrogen itself is going like, I don't really want to be hydrogen right now. And seeing a bunch of other stuff going up on Twitter. I'm going to head back over to the Q&A app because, again, and also a friendly reminder from Thad yelling in the background. But for those, please make sure to have solar glasses out there. I've heard of many different people trying different things to, like, I've heard of welding goggles and stuff like that. And the thing is, they're not rated for looking at the sun. So even though they might seem like it's not bad, not hurting you. Just go with things that are rated for being able to look at the sun. And
Yeah, yeah, it's much
they're
better. And
monolithic, but many different places, many planetariums will have them there. What's that, Katie?
yeah, and they're pretty cheap. They're pretty cheap. I mean, solar glasses are not, a sort of specialty equipment. You can get them for very little money and just have them around for when eclipses happen.
So I have a question here from the Q&A app, and so I'm going to let us both tag team this, and maybe we can bring it down a bit. So Zachary Brown, who has the symbol of Batman, is going, I don't speak geek, so may you speak English, please? So let's try to, I don't know, let's see if we can bring this down a notch. I try really hard not to speak in much jargon when it comes to our broadcasts. So what is essentially going on is that my focus is leaving, so I'm losing my view of the sun. So perfect, so let me get that back. Come back, sun. So I'm going to try to fix that, but really what's going on here is that the sun orbits, the Earth orbits the sun at a very specific orbit, and the Moon orbits the Earth at another very specific orbit. They are not completely in line. So every once in a while, though, those orbits, the planes of them do intersect. They have nodes where they do line up. This one is just not lining up perfectly. So what that means is that we're having a partial eclipse for blackness, as you're seeing now. So I'm going to switch over to Katie's image right here so I can get a better view of my telescope, or my binoculars. It's still giving Thad a bunch of pressure on getting his image in. How else would you explain this, Katie?
Well,
I'm going to turn my back to the microphone real quick while I try to get my optics going again.
okay. I'm going to explain it by showing you a picture. Now let me find a better picture. So basically the orbit of the moon is around the Earth is slightly tilted with respect to the orbit of the Earth around the sun. So you have the sun here, and you have the Earth going around the sun, and you have the moon going around the Earth. And that plane is a little bit tilted with respect to the sun, the plane of the Earth going around the sun. And so every once in a while you get perfect alignment set up so that the moon and the Earth and the sun are all lining up exactly right. And when that happens, you can have the moon completely blocking out the sunlight on the Earth at particular points. And that's when you get a solar eclipse. I'm trying to find a good so I can show you how's the setting up going over there?
I have to turn around and I'm blindly guiding with my hand.
Alright, do you like a live podcast or something?
Bad about focus? Focus, my son. Yes, you have been out for a while.
Oh yeah, I just got it. You remember the conservation, right? Where they're like getting their percentage? Alright, you're not gonna like it.
So, did you find what you're looking for, Katie?
Yes, I found what I'm looking for, and I'm just gonna put it on.
And I know too, speaking of a few things, that Bill Plate put up a great article on Slate that I recommend everyone check out. I did tweet it out earlier on my handle science Scott. But it not only it talks about different live events, like hours, but
I can't,
and I hear celebrate.
there's so many people around you making noise, I can't hear what you're saying.
Yeah, I know. There's lots of loud people here. Let me see if I can turn my mic around and make it more
That's
directional. Is that better?
Yeah, that's great.
Okay. Cool.
So let me show you this image. So this is just a sort of diagram of the geometry of what happens during a solar eclipse, and you can see that you have the sun and the moon is blocking out the light of the sun at a very small region of the surface of the Earth. So if you're sitting there right in the shadow, then you see the solar eclipse. Now you can also see from this picture that when the moon is on the other side of its orbit, you can also have it lining up to where the sun and the Earth and the moon are lined up, where the Earth would be blocking the light from the sun on the moon. So that's what happened a couple weeks ago when we had the lunar eclipse. The moon was on the other side of the Earth, and the perfect alignment happening there to block out the light shining onto the moon.
She's sweet now.
And not the children fire.
And I think Thad's finally getting set up here to be able to join us on the show. And
Are you still there? I lost the connection for a minute. Scott?
oh, are you back?
Yeah. I lost you for a minute there.
There you go. I found you.
Okay. I have one more diagram to show. So hold on a sec.
Okay, looks like we need to make sure I know which telescope you need.
So if you want a version of how the alignments work out for eclipses in emoji, I've got this that I prepared for Twitter. So in a lunar eclipse, you have the moon is on the other side of the Earth from the sun, and the shadow is cast on the moon. In a solar eclipse, the moon comes between the sun and the Earth, and there's a tiny shadow cast on the Earth. And of course, if you get it all terribly wrong, then bad things happen. So
What sort of bad things happen? Sorry, I was facing away real quick. So bad things happen.
Yeah, it was a Twitter joke. It was an emoji joke. But that tweet. So when I tweeted out that sort of, this very silly emoji diagram of lunar eclipses and solar eclipses, that tweet now has 4,465 retweets, which I think is kind of crazy. But people like cute little diagrams of apocalypse. So what can I say? I've also
yeah, I mean, it's not.
Yeah, I've lost you again. Okay, so it seems like there's some connection issues going on there for Scott. So I'm just going to talk a little bit. I just want to show you guys again the website for the Solar Dynamics Observatory, because it's pretty cool. So here you can look at all the different wavelengths of light for the sun, from sort of ultraviolet to extreme ultraviolet and X-ray, and then there's H alpha, and various composites where you can really pick out very interesting features of the of what the sort of radiation from the sun is doing. And then they have various different ways to look at sunspots, and there's also sort of graphs of just the raw data coming from the sun, and other ways of visualizing the surface of the sun and the activity going on the surface of the sun. So it's definitely worth checking that out and seeing what's happening with the sun now. And it also gives you there's also information there for if you happen to be at the kind of latitude where you can see aurora, then those kinds of websites will tell you when the sun is active enough to give you a really good view of the aurora. So check that out. In the meantime, how's the sun going now, Scott? Can you see anything? Yeah. No, it sounds like there's some connection problems going on. So I'm going to look at the questions coming in on the question Q&A app. So let's see. We've got somebody has put up a somebody's put up a table of when and where things are observable. I can't seem to access the Q&A app, but I will put up that table. Wow, okay. So there's, let me see. So thank you to Cecil Morgan for tweeting out this table, or sending out this table on the Q&A app of when and where the partial eclipse is observable. You can find this on the eclipse.gsfc.nasa.gov website. There's lots of good information from NASA on all of the eclipse goings on. Scott, are you?
I think I'm back.
Okay.
Yeah, I don't know. Something went down with the internet.
Okay.
Thank you for entertaining everyone and keeping them company.
I'm doing my best. It's still early.
And I think
here,
Thad
and
is
I'm not-
also trying to get going too.
Yeah, it's almost there. The option to get onto Google Plus or to get onto a video.
It's okay. And what I'm going to do is I'm going to move my bandwidth down low and see if that will help. But I think it just might be bandwidth usage right now.
Okay.
I'm not getting any of the nice little sidebar stuff on Google Plus or Hangouts.
I'm going to show you one more sun picture because I can't get enough of these things. So this is a picture of the sun in. And the thing I love about this picture is not only see the sunspot in this active region, you can also see this really cool dark sort of tendril over there, which is a bit of field coming out and some light from the sun. So you have this sort of flare coming out, and it's basically sort of casting a shadow. And you can get those tendrils going on in places showing you what's being sort of thrown out by the sun. You can see on the edges some of these prominences as well. Very, very cool stuff. And this is all, very up-to-date imagery. This is from, earlier, well, I guess maybe something like 9 hours ago. So really, really recent.
And I'm not ignoring you. I'm trying to get this image.
It's alright. It's alright. I'm seeing little glimpses of the sun.
Amazing view.
Stay. It is not helping that it's windy. I need a production assistant. And I think I lost you again. So.
No, I can still
Oh wait,
see,
no, you're there.
I can see the image sort of flitting around. It looks like the eclipse is getting pretty far now. How close are we to maximum?
What time is it? Because I can't see
For you, it is
the timer.
3 p.m. A couple minutes after 3 p.m.
Okay. So yeah, I believe from what I was looking at earlier, maximum is 329, but that might be different from this latitude.
Okay, so you're pretty close to maximum.
I'm trying to get this going. Yeah.
Hey, how's it going?
Now I'm just going to pan, stay. Yay! You can jiggle for a bit as I kick the mount. Yes! Yes!
I guess this is a good illustration of the fact that not everything always goes right in astronomical observing.
No, it's not. And
yeah. So I'm a theoretical astrophysicist, so I almost never touch actual telescopes or do anything with the sky. So I never really have to deal with clouds and wind and things like that, which is really nice. The only thing that can break for me is my computer or my
it must
brain.
be really nice. And we don't want that, because I rely upon your brain a lot. I really do.
And I find it very useful sometimes.
Yeah, I mean, but specifically, I rely upon your brain a lot for many of the things that we do as far as doing science outreach. Is you definitely bring a lot to the table, and I really appreciate you being able to wake up super early and help us out with this. And I think I have this image as stable as I can get it for right now with this horrible, horrible wind keeping it in, and that is trying to jump in.
It's still pretty cool. I mean, that's it. You can see that the sun is.
I'm still loving that
active
region.
Yeah.
Let's see if I can focus a little better on that.
Is this your recording or is it online?
Yeah, this is live from this telescope.
If you want to see the solar eclipse and you're in a place where it's happening, you don't have solar eclipse camera, solar eclipse glasses, and you don't have a telescope with a nice filter. There are some ways to without turning out your retina or the on-fin special equipment. One of the things that you can do is you can have a pool camera.
Yeah, so it's still
With the prominence, what you do is you put basically what sounds like you put a pinhole in a piece of paper or something like that, and then you take a piece of paper with a hole in it and you hold it up so that the sun is shining on the piece of paper, and you put something on the other side of it, and when the light goes through the pinhole and projects onto whatever you've got on the other end, you'll be able to see the shape of the sun through that as the light that gets through the pinhole. So I've taken some pinhole camera. I'm taking some pictures of this sort of pinhole thing on previous eclipses, and it can actually be, reasonably. You can get a reasonably picture of the eclipse, of what the shape of the sun is doing. You can also see it sometimes if you look at the light passing through leaves of the tree. If you look at the light, sort of the dappled light on the ground from the light coming through leaves on the tree, you can see little crescents sort of lined up on the ground from that, which is also a really cool thing to be able to see. So even if you don't look directly,
yeah, we're starting to get that now. I'm seeing some of the right. I'm starting to get some of the diffused shadows right now coming through. It's one I like it when you cross your fingers together, so you hold your four fingers out and cross them
like that.
Okay.
Here, let me click on you real quick and show. Yeah, just like that.
Can you send me something to join the Hangout?
And then just look at the
So
light.
if you do something like that, you can see the shape. And I'm sending Thad an invite. Hopefully he gets it.
Real quick, I have the.
Maybe he can finally join us.
Put it in the box.
Put it in the box.
Yeah.
You should have notifications, Thad.
Okay.
We can see this in H alpha.
I want to show you until before that comes on a pinhole camera, the sort of pinhole eclipse picture I took when the eclipse was happening in 2012 here in Melbourne. So this this is a picture I drew on a piece of paper in pen, and so you can see that's the sort of scale of this. And I had just a pinhole and another piece of paper. I projected it onto the piece of paper I drew on, and you can see the shape of the sun really clearly in that pinhole picture. So, so you can look at that and you can get a really nice image of the shape of the sun during an eclipse, which is a fun thing to be able to do.
I love it. And I think that's doing this. I just muted him because I'm getting a lot of noise. But here's his image. There we go. And I'm going to mute him because he can hear me. And can you mute yourself so that you're getting
Yeah. We're going to mute myself. Yeah, I'm muted.
Yeah? Okay. He's muted now. So this is Thad's view. We're looking at it through hydrogen alpha. So you're able to see some of the filamental structures there and some of the sunspots as well. Are you able to bring the exposure down a little bit?
Yeah.
I know I'm being demanding. I'm such a mean, evil producer. But where? And I'll move mine over a bit. And so his is going to be upside down just because of the way that it's set up with the camera on his eyepiece. But it's the same sun, I promise. He's not standing on his head. At least I don't think he is. Let me see. I'll take a picture of him. Nope, he's standing straight up. And I have my DSLR out here. So I'll have a lot of pictures that will go up onto the event page when we're done. What's that?
Upside down. I was just pointing that out. Earth.
You there, Katie?
I'm here.
So it looks right up to you. Yeah.
While you're setting that up, I'm going to screen share another silly eclipse
refresh.
picture
And
in
so
2012.
answer real quick? I have the mission analysis. Can I drop it in there too?
Yeah.
That looks good,
Have a
Thad.
good day. Hey, good one. Thanks.
So I'm screen sharing another picture.
So this
of
is
that.
from, you said, 2012?
Yeah, this is from 2012, and this is again just a pinhole camera, sort of pinhole projection of the eclipse, the partial eclipse, and then maybe a little picture around it. Because it's fun, because it's astronomy, and astronomy is awesome. Are you still there? Okay, it sounds like I've lost you again. I don't know if, okay. It sounds like I've lost everybody on the call again. We are having technical difficulties. So anyway, so the point of showing all those pinhole camera kind of pictures is that you can definitely experience the eclipse and see how the sun is being partially blocked out by the moon, even if all you've got is a piece of paper and a stick to put a hole in it. So you don't need anything special at all. Don't look at the sun directly. That's really important. But you can look at the projection of the sun in sort of in pinholes or even just in your hands, and you can see what's happening in space, how the moon is coming between you and the sun, just by looking at stuff like that. Thad, are
So
you
Katie,
there?
I don't know if you can hear me. I'm back
Yeah,
on.
I can hear you. Good.
And Katie's just
Excellent.
explaining.
So this is your hydrogen alpha picture of the sun, the stuff now? Are you there, Thad?
Yeah, sorry, Katie. Don't mean to just leave you out there by yourself.
That's okay.
Scott's trying to get back in here.
Okay, no problem. That's a great image you've got there.
But yeah, there's terrific filament. That's
Yeah.
just off the one limb of the moon there, and then there's that active region 2192. Now, hopefully, we do not see that brighten anytime while we're watching here. If that thing brightens, that means there's been a giant flare. Flares usually do not show up in visible light. And so if a flare shows up in visible light, it's duck and cover time.
So can you tell us something about solar flares and just active region? Should we be worried about what it's going to do? I know that it put out a pretty big flare a few days ago. What does that mean for us? Are you there, Thad? Okay, it sounds like at the moment Thad and Scott are preoccupied with getting these observations going. So so I will tell you some more about solar flares. So we've had a few big solar flares recently. This one has given us some pretty big flares coming toward the Earth, but it wasn't aligned exactly with us when it put out the big outburst a few days ago. So we got a big flare, but it was not nearly as powerful as it would have been if the sunspot was actually pointing toward us. Now the sunspot is more in the center of the sun, and it's closer to pointing toward us directly. So I think that if it goes off again, if it gives a really big flare, then we'll see some pretty exciting stuff. And Thad, are you still there? Okay. So most of the time, what happens with solar flares is that, or coronal mass ejections, which is where you get sort of a big outbursts of ionized gas of high energy particles from the sun. Most of the time, what happens when those go off is that you get charged particles from the sun coming and hitting the atmosphere and creating aurora at high latitudes or at, the north and south poles. And so it can be really cool to watch when that happens. Occasionally, it'll be strong enough to actually affect our radio, our sort of communication system. It can affect our satellites a little bit by just sort of overloading them with energy. And in really extreme cases, there can be enough sort of charged particles being put out there and enough going on in the atmosphere that you can actually put a lot of electromagnetic energy into the atmosphere and blow out transformers and really mess with like the power grid. That's rare. That doesn't happen very often, but that has happened in the past, and that's something that could happen again if a really big flare from an active region that's pointing right at us goes off and sends off a coronal mass ejection. So it can be problematic for satellites, and it can be potentially somewhat problematic for like our communications and power grid. But usually it's not so extreme, and so it's one of those things that people do monitor. There's space weather monitoring, and these solar observatories keep an eye out for that stuff to find out if we need to sort of shield things or put satellites in safe mode or whatever. But usually it's not anything to worry about. Usually what happens is that we get really nice auroras at the north and south regions of the Earth, and so you can pay attention to the space weather stuff to look for that if you're in a place where you might be able to see auroras.
Katie too. So I'm going to assume that I'm live right now.
Yeah, I can.
We'll figure out what's going on there with that. But for those of you who have joined us, and thank you for all your patience while we've been going on. This is our view of the solar eclipse. We're about to reach maximum here, and it's a little windy out. I'm right now using a Celestron binoculars and also a webcam, and it looks like people are bonking things over here. So we're on campus over at Cerritos College, and this is in Norwalk, California. And there is, it's not necessarily an outreach event that's happening right now. It's a class for Dr. Thad Szabo. So what they would normally have lecture, they're actually coming out here observing the eclipse and sketching it. And he invited me out here to help try and broadcast it. I think he's trying to get his camera reconnected is going on here, but we are just about to be reaching maximum.
So I think we've lost Scott again, but we've still got that gorgeous image of the H-alpha sun, and you can still see that beautiful prominence, that beautiful filament just near the edge where the shadow of the not the shadow, but the light being blocked by the moon is touching the sun. So you can really see how that light is being blocked, and how that blocked light is kind of moving across the face of the sun. So that's really cool to see. Thad, are you there? Can you hear me at all? No, it's just me. So let me see if I can do anything with the Q&A app. So I'm looking at some of the questions that you guys have had. So someone is pointing out that we're nearly on the sunspot. So that's so the It's not. I keep thinking shadow. It's not the shadow. It's the actual blocking of the light from the moon. So you could the blocking of the light from the moon